Is Pjotr Prins, and he's going to talk about small tools for bioinformatics.
Thank you, Raoul. I'm back. So I have two talks, and I could drift from one to the other, which is quite fortunate. Last talk I had too many slides. I probably have too few now. Yeah, so I mean, it's very interesting, this BOSC, I think. We just heard a talk by Hilmar about Scala, or a Scala-based tool set. Almost every talk has got a different language, right, underneath. And somebody just asked me, aren't we creating our own Tower of Babel here? And maybe we are, but I think we can work around it, and that's in the good old Unix tradition. So what are we up to? Large-scale data acquisition is giving us problems. Scalability, scaling calculations, storage, especially data integration, different standards that people are using, and we need to integrate them somehow. I think the state of the art at this moment is to pull a CSV file somewhere from the internet and do something with it. We also have challenges in data exploration and visualization, and there's many people working on that now. I'm kind of excited about what the Bio.js people are doing, because they seem to be on the right track. And related to that, we have tool integration, versioning. A number of talks were about tool integration. Versioning, nobody really touched on. Workflow management, not many talks about that here. Changing environment, tools, provenance. And we've got all these different environments we have to deploy on. Clusters, which we don't have root to. Cloud environments, supercomputing environments, grid environments. Again, data integration, annotation of data, visualization, user interfaces. And there's a lot of duplication of effort going on. You may have noticed that. So in a way, I'm preaching to the converted, but in bioinformatics, why is it so often that we have not invented here? I don't think it's here much here the case, but well, the Galaxy project is an example. A lot of stuff in Galaxy projects, they rise from scratch. Why are some people opting for monolithic solutions? If you look even at the BioRuby or the BioPython project, we put everything in one huge space. Why is that, right? Why do we choose to go down that route? And when you ask this question, you get a number of answers. And one of them says, one of the things people consistently bring up is deployment, right? I mean, we put everything together because we don't want all these dependencies, which is really a deployment issue. Also, there are organizations who want control. GATK of the broad. I tend to say broad, but that's something else. It's a bit of a disaster. Ask a few people here. You can hear what problems they're confronting with that. So that's a monolithic type tool, where an organization wants to keep some type of control because they want to make money out of it. I don't know. And also people answer, biologists ask for it actually. They want to have a tool that they just can install and don't worry, right? So to fight that, we've drafted a manifesto, which is online. The URL is at the bottom. And basically says, the Unix tradition has been there for almost 50 years, and it's still going strong, so the Unix people must be doing something right. And what they do is really provide small tools. And these small tools you can plug together, using pipes or whatever, or using REST. There are many ways of wiring things up together. And the main advantage of that is the flexibility. You get a modular system that is pluggable. And you also get efficient computational solutions, at least with Unix pipes. When one tool starts pushing out data through the standard out, another tool can pick it up and start processing also, and that happens in parallel. Individual parts can easily be replaced. So far we've got 50 stars for the manifesto. I hope a few people will start this also. 35 forks of the repository, and 26 people actually signed it. So you can also sign it. in essence, what the manifesto says is that a small tool should do the smallest possible task really well, right? And I think that's a challenge for developers. You know, in the way you have to think about when you create your new software tool is what is actually the smallest task that I can define that my tool does, and create a separate tool for that, create a separate repository for it. Publish it on an open source license. Use the command line and pipes if possible, or a REST structure or whatever. Yeah, as long as you know allow people to. Well, in one way to look at a small tool is that it's a function, right? You have input, you've got output, right? So that's the way to pursue it. And then there's some other stuff which kind of makes sense to many people. But oh yeah, the bottom one is important. I think also the structure. I don't know if you know the coin term anti-fragile, which is the opposite of fragile. In evolution. The way evolution works, it's anti-fragile, right? We go in different directions. Evolution goes in different directions, tries things, and the things that works in the end, you know, sort of survives. I think we should look at software in the same way. And small tools allows for so you can plug and play with them. Did I go the wrong way? Yeah, sorry. So I'm going to present 3 tools. One is which are interesting. One is called Probabilistic file fingerprinting. It's actually published in a paper. I didn't put the references, I'm sorry. It's written by Konstantin. And what it really does, it's a drop-in replacement for MD5 hashing. And what Puff does is rather than reading the whole file, it just takes samples from the file, so fingerprints. And in general, that we actually prove statistically that it's as reliable as MD5 for large data. But it has a flat performance characteristic. It doesn't matter how large the file is; it will always have the same time. So this is very interesting for people who are dealing with file comparisons, and that happens a lot in sequencing centers and all that. And the reason we could do that is because MD5 sum itself is a small tool. You can just replace it. Another example, this is Sambamba. It was written by Artem Tarasov as a Google Summer of Code project. And it's the fastest SAM-BAM parser on the planet. And it's being used in many pipelines today. And next to its advantage in speed, it has also powerful filtering, etc. At the moment, we're adding CRAM support. Another tool, which is written by myself, is the fastest VCF parser on the planet, and surprisingly, it's written in Ruby. And why is it the fastest? Because it's multi-threaded. It's actually 50% slower than its Java competitor, which is SnipShift. Yeah, so that's pretty amazing in itself, and that's because I'm using Ruby, and Ruby itself is probably 4 to 10 times slower than something that is compiled on the JVM. But I'm using laziness. I don't turn everything into an object, and that's what SnipShift does. So the manifesto is really about creating modules, plugins, packages. Design software so it can be wired up. It's important to design software that can be replaced with something else. Yeah, we need. And in bioinformatics, the reality is that most software is written as a one-off, as a prototype, you can say. I mean, some tools is a great example of that. It's an amazingly interesting prototype, but that's what it was. Hang Lee at the time drafted the standard, SAM and BAM, and created a tool for it, and he did it really well because it was a surprisingly fast tool. But people who wanted to change the tool and modify the source code got really frustrated. It's surprisingly hard to read code, and that's maybe part of the genius. Yeah, but if you want to move on, you need to move to the next step. And we, as we read the code, and then we decided to rewrite it in D. The other thing is to design software for failure, and that's something that people don't do either. Yeah, so that's something to keep in mind. With more and more of these complex systems that we're building up and software depending on other software, yeah, it is going to fail. It's going to fail. It's failing all the time. So, packaging. I mean, one reason people want to put everything in one space, right, is because they say, okay, you know, we don't want to deal with the dependencies, so we create one system. You install it once, and you've got you know, the kitchen sink included. And there are many packaging systems out there, which is part of the problem, right? But actually, there's a new packaging system that's called GNU Geeks. We saw it at the Coast Fest. There was a presentation by the Free Software Foundation. And GNU Geeks is actually a very sophisticated package manager that gets it right, in my opinion. And it's actually not, I mean, it's announced less than a year ago, but it's based on a packaging system called Nix, which has been around for more than 7 years. And the GNU project has picked it up. And it's very, very interesting. It's gaining momentum rapidly. I think, you know, if you look at GNU Geeks and the way they've done it, dependencies and versioning are actually solved problems. So, when you're dealing with your own project and you say, okay, I've got this small tool and it's depending on some library or depending on some other stuff, right? I suggest you look at GNU Geeks and actually package it, right? And it should be running on everything that supports GNU. So GNU Geeks, one take-home message I want to give you is that it's a game changer. Yeah, fast probabilistic fingerprinting could also be a game changer. Sambamba is a game changer already. BioVCF I hope to make a game changer. There's Biotable, which parses, filters, rewrites tabular data. And there's another tool which is once only, which is based on PUF, on the probabilistic fingerprinting, which allows you to run a command line tool with its inputs, and it parses the command line and it does a checksum on all the files that are on the inputs, and it generates the output. And next time you run the same command with once only, it won't rerun the command if the output is already there, and it matches the inputs. It's quite a useful tool. So, that's my talk. We have some space for questions.
Questions?
Pjotr, I assume you want us all to do the things the way you proposed and refrain from our old ways of building big monolithic infrastructures, right?
Right.
So if we all do that, who's the NIH or the NSF going to fund with its $1 million grants?
Good point. Well, you know, if you look at Galaxy is in essentially also a stack of small tools, right? It's using tools that have been written by a lot of other people, and Galaxy itself is also built of components. And Galaxy is quite successful in getting funding, right? I mean, it's also the way you present. I mean, what you present on the outside doesn't reflect what's in the inside. That's my answer. Peter.
I've read the manifesto and I agree with it, but I haven't signed it yet because I'm not living up to it.
Well, it's a declaration of intention.
In that case, I ought to sign it.
Please do.
Thank you.
Yeah, so please sign the manifesto if you agree to it. Yeah, I think it will have some impact.
We do have time for a couple more questions. Or we can do announcements and maybe get you to lunch ahead of the
Yeah, time for lunch.
Right, announcements.